Hi guys, it's Mr. Ward, day 3 of Unit 10 on trig inverse functions. We're going to do a quick warm-up. We're not going to spend a lot of time on this because we've got a lot of applications today. We're going to do things with what we've learned. All right, let's go quickly. What angle has a sine ratio of 1/2? The answer is 30 degrees pi over 6 radians. What angle has a negative 1/2 ratio? Negative 30, negative pi over 6. Easy. What angle has a cosine ratio, radical 2 over 2, 45 degrees, aka pi over 4. What angle has a cosine ratio of negative? This is the one where I wanted to spend some time on. Cosine ratio negative, we can't just negate the angle. We have to move to the second quadrant. So in degrees, it would be 135. In radians, it would be 4 pi minus 1, or 3 pi over 4 radians. For the cosine only, you're going to do second quadrant angles. And let's do sine arc cosine. Arc cosine 1/2. What angle has a cosine ratio of 1/2? The answer would be 60. But in the second quadrant, the answer is 120. And now we're going to take the sine of that 120. Sine of 60 is radical 3 over 2. Because I'm in the second quadrant, the sign stays positive. So even though I started with a negative ratio, I can finish with a positive ratio. 3/5, I don't know that triangle. It's not one of my family members, so I'm going to draw a reference triangle. Theta is there. What angle has a cosine ratio of 3/5? It would look like that. Tangent, I need opposite. Blank 3, blank 5. 3, 4, 5. Pythagorean triple. So the tan would then be 4 over 3. All right, that's good. We'll skip that last one. We just got a couple nice ones for warm-up. All right, let's move to today's notes. And we got a reference triangle to begin. Sorry, I got some answers on here. I didn't erase them up pretty good. Let's start in a vacuum. Solve for R. You would say 40 relates how? 15 is opposite. R is hypotenuse. It must be sine. Sine of 40 equals 15 over R. R equals 15 over sine 40. And I'll round it to the nearest tenth if it's a side. 23.3. Beautiful. All right, let's do it. Val just wants to study water pollutants of a river. To set up her instruments, she must find the river's exact width. She first selects 2 points on opposite side of the river, X and Y. Then she walks 150 feet downstream for this point Z. So what's that mean? Well, if this is the river, we have 2 points, X and Y, directly across from each other. And from X, she walks 150 feet downriver to point Z. And when she spots Y, the angle she sees is 54 degrees. So that's the angle at Z. So on that triangle, I want to find the river's width. I'm going to put my unknown right here. Call it X. I used X already. How does the 54, the unknown, and the 150 relate? I'm going to call it W for width. I would say tan of 54 equals W over 150. W equals 150. Tan of 54 to the nearest tenth of a foot. 206.5 feet is the width of the river. Nice application for the one we did in a vacuum up here. Same exact thing. Let's keep going. We got a bunch of these for today. Again, I apologize I didn't erase these notes. Nope. Use my calculator. All right, what do we got? A man 6 feet tall. He walks from the base of a broadcasting tower directly towards the tip of his shadow, towards the tip of the shadow cast by the tower. So here's my tower. Here's the sun creating a shadow. The man walks away from the tower. When he was exactly 132 feet from the base of the tower and 3 feet from the tip of the tower's shadow, he saw his own shadow starting to appear. So he is 132 feet from the tower. He's 3 feet from the shadow. He is 6 feet tall. From that, can we find the height of the tower? So let's do this. Let's find theta. We know 6 and 3, so that's tan. Tan theta equals 6 over 3. Theta equals tan inverse of 6 over 3 to the nearest tenth of a degree, 63.4 degrees. That goes right there. Now we need the whole side on the bottom, which would be 132 plus 3 or 135. We're now going to create an equation almost like we did the other day. Go from ratio to angle, back to ratio. Tan of 63.4 equals T over 135. T equals 270 feet. All right, let's move it on. From a point, you know what? Let's steal this diagram. I'm not going to erase it. I'll erase the work. Might as well use this. From a point 100 feet from the base of a library, the angle of elevation to the top of the building and the top of the flagpole on the building are 28 degrees and 39 degrees respectively. Find the height of just the flagpole. So here's what I got. Here's me. I look up 28 degrees, I get to the top of the building. I look up 39 degrees, I get to the top of the flagpole. And I'm 100 feet away. I'm going to label these as 3 things. I'm going to call this building for B. No, can't use B. I want to use B for both. Doesn't matter the letters, but I'm just trying to be fancy. Let's call this X. Let's call this A. And let's call this B. So I'm not going to find X directly because that's not a right triangle. I need to use the bottom. So I'm going to create a bottom triangle and a top triangle. And the bottom triangle is going to be the A, the 100, and the 28. Tan of 28 equals A over 100. A equals 100 tan of 28. A equals 53.2 feet. Tan of 39 equals B over 100. B for both. B equals 100 tan of 39, which is 81.0 feet. And how do I find X? X is just the difference of 81 minus 53.2. So the flagpole by itself is 27.8 feet. We had to take that indirect approach because it wouldn't be a right triangle otherwise. All right, let's keep moving. And again, we got an illustration. Sweet. You know what? I don't like it. Part of the question is setting it up. It says a plane flies 120 miles due north, then 85 miles east from an airport. If he wants to return, what heading should he take? Well, the convention says, and you guys know this, math, social studies, north we always put up, south is down, west is left, east is right. So if the plane's going to fly north from the airport, he went up 120 miles. If he then goes due east, 85, he went to the right. And question 1. What if I wanted to fly back to the airport and find its distance? Answer, Pythagorean theorem. But I don't want to find that. I want to find the angle. So I'm first going to find this angle right here. And we say theta equals, 120 is opposite, 85 is adjacent, so it's tan. Tan theta equals 120 over whole unit on trig inverse functions is all about this. Finding angles. Tan inverse 120 over 85. Theta equals 54.7 degrees. However, you need to give it a direction, meaning 54.7 degrees, which way? So it's in the bottom left, which would be the southwest, which means you would add 180 to it, or better yet, subtract 270 minus that, because you got to go always off of north or south. That's how headings work. And 270 would be right here. So 270 minus 54.7 is 215.3. That's what that angle would be, all the way around. Or 54.7 taken away from 90 is 35.3 degrees. But if you're going to make an acute angle, this is the one you want to find off of north-south. You have to attach the two headings of the quadrant you're in. Third quadrant is southwest. 215.3 and 35.3 southwest are the same angle. We'll do more of those on a little while. All right, next one. Again, part of the fun is the illustration. Pilot is flying in an airplane, and he looks out the left side of his window, and he spots two cities. One city he spots at an angle of 18 degrees, angle of depression. There's a plane, he spots it here. Angle of depression is right here. This is how much he had to look down. Not much. That's city one. Then he spotted another city at an angle of depression of 55 degrees. And that's city two. Okay? Flying at 30,000 feet. So we're going to find this distance right here. We're going to use that to find how far apart the two cities are. All right? Or two towns. Now, I don't like the angle of depressions. You learned this in geometry. If it's an 18 angle of depression up here, it's an 18 angle of elevation there. 55 depression here, 55 elevation here. I'm now in the triangle. Okay? And I'm going to do it almost the same way that I did it before. By the way, since I want to do miles, I'm going to convert 30,000 feet to miles, which means I've got to divide by 5,280 feet to get miles. Remember that stoichiometry. 5.682 miles up in the air. So now we can create a couple equations. I'm going to find A. I'm going to find both. And I'm going to subtract to find B. Equation 1, tan 55 equals 5.682 over A. A equals 5.682 over tan 55. That is 3.979 miles. My next equation, tan 18 equals 5.682 over B. B ends up being 17.487 miles. When I subtract 17 minus 3, I get 13.5 miles between the two cities. Tan, and subtract. Sounds like something you did in geometry. All right, I have a couple more application questions. We'll pick them up on the next video. It's time to go. Great job today, guys. We'll see you.